Hello, geometry friends. Today we're going to talk about partitioning a line segment. So I need to make sure that you have your notes out and turn to day 9. And we're going to talk about partitioning. And we're going to start kind of entering what the heck does that even mean, and then do it on a coordinate plane. So let's get started. Now, first, for some reason, when we printed this, a letter was missing. This should say PA to PB. This should say PA to PB, and this should say PA to PB. I don't know why the A's are gone. They just disappeared, so please put them back in. All right, next, here is a line segment. It goes from A to B, and A to B goes from 10 to 20. Okay. Part A says, find a point that's half the way from A to B. Well, that's easy. And also, that's going to be 15. Not a problem. What is the ratio of PA to PB? PA to PB means how long is PA, and that's 5. And how long is PB? That's 5. So technically, the ratio from PA to PB is 1 to 1. Because what we do is we take 5 to 5 and reduce it. Because ratios can be thought of as that colon thing, or as a fraction. And 5 over 5 is the same as 1 over 1. So PA to PB is 1 to 1. Cool. So halfway is a ratio of 1 to 1. That's something we're going to want to look at. Part B, find the point that's 3/4 the way from A to B. Okay, so 3/4 would be like right here. Fine, and I'm going to call that P. What is the ratio of PA to PB now? Well, okay, if this is 3/4 of the way, that's 10 units apart. So 10 units times 3/4 is 7.5, which means this is 17.5, right? So I took the 10, the length, and I multiplied it by the fraction 3/4 and got 7.5, and then I added that 7.5 back to the 10. So that's 17.5. Okay, I can live with that. So what's the ratio of PA to PB? So PA is 7.5. And from P to B, that's going to give me 2.5. So 7.5 to 2.5 is like 75 to 25. That's a ratio of 3 to 1. Okay. Fine. So 3/4 of the way was the same as a ratio of 3 to 1. Fine. Change colors here just for fun. Now, if I want 2/5 of the way, okay, 2/5, I don't know. So if this is 5 units, this would be 2/5, I guess. We'll call that P. And what's 2/5 of the way down? Well, there's 10 units total. 2/5 of 10 units. 2/5 times 10 is going to be 4. So that means from A to P is 4 units. So PA is 4. And from P to B goes 14 to 20, that's 6 units. And 4/6 is the same as 2/3. Before we jump into some other things, I want you to notice something. 1/2, split it into a ratio of 1 to 1. 1, 1. 1 plus 1 is 2, 2. 3/4 was 3 to 1. 3 plus 1 is 4. 2/5, 2, 2. 2 plus 3 is 5. When you look at the ratio of part to part, the fractional distance is the first part over the sum of the two parts of the ratio. Okay? Because if this is split in a ratio of 2 to 3, what that means is this side has 2 equal parts, that side has 3 equal parts. So this is 2 of 5 total parts. That's where the 2/5 comes from. All right. Now, let's actually do some things here. Using the problems above, show the work that's needed to answer your question. How can we determine the number of units that are in each partition? So we had said the number of units. We did the fraction times the length of the segment. How can we find the distance from the starting point to the new point? Well, that was the fraction times the length of the segment. Oh, you know what? I'm going to be honest with you guys. I'm not thrilled with how we phrase this. So let me explain. The distance from the starting point to the new point is the fraction times the length of the segment. Then it says, how can we determine the number of units that are in each partition? I'm just going to have you cross this off because you know what? I don't really care so much about that. So just cross it off and pretend it never happened. Okay? I promise I'm not avoiding some educational epiphany. Just ignore that right now. Our phrasing was poor. I care about the next part. How can we refine this formula to further allow us to find the actual location of our answer? This we did the starting value plus this thing right above it, the fraction times the length of the segment. So it says, using the answers before, locate the point that's 2/3 the way from 201 to 312. So 201 to 312. If I want to go 2/3 of the way, that's about here. So I need 2/3 that distance. Well, my entire distance from 201 to 312 is 111. And I want to go 2/3 that length. So 2/3 times 111 is going to be, let's see, I'll pull up my calculator. 2 times 111 is 222. That is going to be 74, I believe. But I'm just going to double check. So what was it? 2/3 times 111. And I think that's 74. I am correct. It is 74. Now, that doesn't mean that P is 74. That means that this is 74 units long. 201 plus 74 is 275. Now, I do not want you to think of this process as something you need to memorize. I want you to just think it through, okay? We got 74. That can't possibly be my final answer because 74 isn't between 201 and 312. That's how I knew I had to do something else. And that's what I want you to apply to the next couple problems we're going to do. Okay. Same thing up here. There is a box up here. I personally do not use that strategy. I like to think it through and not think of this as a routine. So the box is accurate. Feel free to read it, but I don't explain it that way personally, okay? I'm just going to jump right into the problem. This problem says the endpoints of ADB are negative 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. Right? 1, 2, 3, 4, 1, 2, 3, 4, 5. Yep. There's A in 6, 10. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Way up here. It says determine the coordinates of D such that AD to DB is 3 to 2. So that means there's a D somewhere so that I have 3 sections on one side and 2 sections on the other. That means I want to go 3/5 the way from A to B. If AD to DB is 3 to 2, that means I'm going 3/5 the length of the segment. So 3/5 down is like, I don't know, somewhere over here, okay? I want to find the specific coordinate that's 3/5 the way down. So let's figure that out. Well, this line isn't horizontal. Instead of one number, I have 2 numbers. The first number I have is how much did I go over? I'm going to want 3/5 of that. The next number is how far do I go up? I'm going to want 3/5 of that. So how far did I go over? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I went 10 units over. And if counting it with your eyeballs is driving you crazy, you can just say, well, what happened to X? X went from 4 to 6, so my change in X was 10. But I don't want to use that entire change in X. I only want 3/5 of it. So I'm going to multiply that by 3/5. 10 times 3/5 is going to be 6. So instead of going 10 over, I'm going to stop at 6. 1, 2, 3, 4, 5, 6. I'm going to stop right here. Now let's figure out how far to go up. Well, y went up 1, 2, 3, 4, 5. So my delta y was 5. But again, I don't want that whole thing. I just want to go 3/5 the way. So 5 times 3/5 is 3. So I went over 10. Now I want to go up 3. 1, 2, 3. So if I figure out where those intersect, it's right here. And that is the exact location of point D. Now, what are those coordinates? Let's figure it out. Over 2, up 1, 2, 3, 4, 5, 6, 7, 8. 2, 8. Okay. There are lots of steps, but you just want to figure out how far did I go in the first place? Let's take 3/5 of the horizontal, 3/5 of the vertical, and figure out where I end up. Okay. That is what also happens in the box here, but I feel like there's so many variables that it gets confusing, which is why I don't use this setup. All right, let's do another one. Another one says, find the point on the directed line segment from here to there, which really just means this is A and this is B. And I want to divide it in the ratio of 1 to 3. So -2, 0 is A, 10, 8 is B. I want to find the point that divides it in the ratio of 1 to 3. So I want 1 part on the left and 3 parts on the right, which means I'm going to use a ratio of 1/4. I want to go 1/4 the distance down. That's probably like here. I'm not sure though. Let's find out. So if I want to go 1/4 the distance, either with your eyeballs or with the numbers, figure out how far over you go and how far up you go. Well, my X went from -2 to 10, so my current delta X is going to be 12 to the right. But I don't want to go 12 to the right. I only want to go 1/4 of that. So I want to go 3 to the right. Let's figure out delta Y. Delta Y went from 0 to 8, so Y went up 8, but I don't want to go up 8. I want to only go up 1/4 of that, so I want to go up 2. So starting at A, I'm going to go over 3, up 2, and hey, look at that. I eyeballed it perfectly. What are the coordinates of that point? That is the point 1, 2. Okay, and I'm just going to call that D for consistency's sake. And that's how you partition segments. You use your noggin to say, how far did I start? Now let's take a fraction of that. All right, bad joke time. It's getting into fall, so I'm giving you bad jokes. What do you get if you cross an apple and a shellfish? An apple and a shellfish? A crab apple. I know. You'll laugh eventually. I'll get you there. I hope everybody is having a great day and you continue to have a great day. This is me signing off.